Hey everybody, so sorry I'm not there today. I am at a math conference to be a better math teacher, but I'm going to go over the notes that the other classes got to go over with me. So our new unit is chapter 5 and it is all about polynomials, so polynomial pattern. And fun fact, you really have been working with polynomials this whole year, and so now we're just kind of putting names and terms to the things that we've been working with. So the first thing is, what is a polynomial? Poly and nomial are stem words. So if you put them together, poly means many and nomial in math means terms, but you also can sometimes hear it be called name, not name, not Nate. And the definition of that put together is an algebraic expression of many terms. And so in math, we're going to talk about many as one or more, combined by addition, subtraction, and multiplication. And notice that that definition doesn't include division. And that's because when we have an algebraic expression with division, it's called a rational function. So go ahead and write that equation down, and then I will show you some examples and some non-examples of polynomials. And then as I go, if I'm going too quick, just pause me. But an example of a polynomial is -7. That one might be like, what? Doesn't even seem like there's any algebra in there, but we'll get there in a second. There is x to the 10th power plus x to the plus 10x plus 9. That is considered a polynomial. -3x to the 1000 plus x to the 9th plus 2x to the 3rd plus 4x to the 1001 power. That is a polynomial. And then this is even a polynomial right here, because these are just connected by multiplication. So that factor form, that intercept form that you guys might recognize, that is considered a polynomial. Things that aren't considered a polynomial are 1 over x, because that is division. 4x to the -3rd power isn't considered a polynomial because this is equal to 4 over x to the 3rd power, which you guys might remember from the homework you did yesterday. If you had like x to the 7th power plus 2x to the 3rd power plus 1 over x plus 1 over 2x, that's still irrational. So even though part of it looks like a normal polynomial, this last part right here makes it not a polynomial. So those are examples and non-examples of polynomials. Okay, now I'm going to go over 2 more definitions with you. So the degree of a polynomial is the greatest exponent of the polynomial. And then the leading coefficient is the number in front, or the coefficient, the number in front of the variable with the highest degree, or with the highest exponent. So the leading coefficient always goes with the degree of the polynomial. So finish writing that down. Okay, so pause it if you need more time, obviously, but I'm going to go through a few examples with you guys real quick. So on the left are the names of the polynomials and then the exact expression. For the first few, I care that you know the names of the polynomials, but there's 2 at the very end that I don't really care. They're just more examples. So our first polynomial is called a constant, and an example we have is 12. And you might think like there's no algebra in there, there's only one term, that doesn't make any sense. But Fun fact, x to the 0 power, which x is algebra, x to the 0 power equals 1. So that is a exponent rule that you might not remember, something we touched on in Algebra 1. And so technically, 12 could just be 12x to the 0 power, because that equals 12 times 1, which equals 12. So that's how this is a polynomial, and that makes the degree of this 0, because the highest the highest exponent in this whole expression is 0. And then the coefficient that goes with our degree is 12. And then if this was y equals 12, this is what our graph would look like. So something like this. It just is 12 at the horizontal line. Okay, linear function. Another fun fact is x to the first power is just x, because anything to the first power is just itself. And so 4x minus 19, that x has a 1, so the degree is 1, and then the leading coefficient is going to be 4. So our degree was 1, and then our leading coefficient was 4. So that's where I'm getting these from. And then the graph of this roughly would look like this. Oops, would probably be a little lower than that. So I just am starting at my y-intercept, which is -9, and then I'd go at 4 over 1. I didn't do it exactly here, but just so we know how you would do that if you're trying to do it really precisely. So that is the linear function, the polynomial. So we've done linear this whole time, and the linear is polynomial. Okay, we're gonna move on to our quadratic. I know you missed quadratics, but you guys probably already know this. The highest degree of a quadratic is gonna be 2. And so something to know is that the degree of, say, a quadratic or a linear or a constant is gonna be consistent across the board. What's gonna change is the coefficient. So in this case, the leading coefficient is 5, but that might not always be the case. But the fact that the degree of a quadratic is 2 is always gonna be the same. That will never change, because it gets its name based on the degree. And then you all know how to graph a quadratic. You all know and you love it, but this one would look something like this. I'm getting that because I know it crosses at 0, -9, because that's the y-intercept, so that would be down there. And then it goes up because the leading coefficient is positive. Okay, next is cubic. So the largest degree in a cubic is 3, and then the leading coefficient that goes with x cubed is 8. And then this one, so all cubics will not look the same, but this specific one's gonna look like this. And then cubic is something you learned at the beginning of the year when we were learning parent functions. So a cubic is normally y equals x cubed, and so that looks like the disco ball one. So it's a little bit, normally what you guys might remember a cubic is it looks like this. Oops, I'll draw a axis so you can see it a little bit better. But this might be what you guys remember about a cubic. And so that's like the easiest, most simple cubic without any other numbers. But this is what maybe a more complicated cubic looks like. Okay, we have 2 more. These ones are the ones I don't care about the name. I just wrote the name for consistency, but when the highest degree is a 4, which is the case here, it's considered a quartic. So the highest degree of this polynomial right here is 4, and then the coefficient is 7. And then these graphs start to get a little funkier. So this one looks like this, kind of like that. And then this quintic one, the highest degree is a 5, and don't worry about the name. So it's just a polynomial with a degree of 5, and the leading coefficient is 12. And this one, I drew a picture of it earlier. I don't know if I remember what it looks like. Okay, this one's really funky. This one looks more like this. And then as you're wrapping this up, I want you guys to answer this question. What do you notice about the graph as the degree of the polynomial goes up. There's no right answer, so I just want you to write observation. So what do you guys notice as the degree of the polynomial goes up? Okay, so the notes are over, but I want you guys to go, I'm gonna do a few example problems for you guys. So I'll like stop and have you guys guess because I did this with people that were in class. So I'm just gonna give you a few I want you to think about. So this first one is, let's do 3x fourth minus 7x cubed plus 2x plus 1. And I'm gonna go through these quick. So I want you to pause it, think about it, and then I'll write the answer. Like I'm gonna write them instantly. So if you wanna answer, pause. But this one, I'm gonna write LC is 3. And then degree is 4. Is 4. Okay, so that's one. Okay, I'm gonna give you another one. So again, pause. This one, the LC is 6 and the degree is 12. And so you might have thought the answer was the LC was 12 and the degree was 5, but normally people will write the degrees from greatest degree to smallest, but sometimes they might not do that. Sometimes they might write it in a different order. Maybe they want to trick you, but notice that 12 is the highest degree. It was just not written first. And actually this should be -6 because that is the leading coefficient is a -6. So that's an example. Okay, I'm gonna give you a few more. Okay, think about this one. Okay, the leading coefficient here is -9 and the degree is 9. And that a reason for this one is because this one, again, you would hope that they're always simplified, but this isn't simplified all the way because these these terms both have x to the 9 in them, which means all the like terms haven't been combined. So if you combine all the like terms, it would be -9 x to the 9th plus 6x squared plus x plus 2. So that would be -9 and 9. So that one might have tricked you, but that is the answer. I'm gonna do 2 more examples with you. Sorry, I'm flying them through them, but again, pause, unpause. If you have more questions, let me know. So the next one is gonna be 3, I keep using 3. -2x squared times x to the 3rd power plus 6x. Okay, so this one, leading coefficient is -2 and the degree is 5. And so you might have thought the leading coefficient was 1 and the degree was 3 because this is like the largest single number we see in there with a high degree, but these are connected by multiplication and they're not in the standard form. And so if I were to actually multiply that out, it would be -2 x to the 5th power plus 6x. And the reason it's x to the 5th power is because x squared times x third. When you multiply variables with exponents, you add the exponents. So it's x to the 5th. So after I distribute that out, I'll get -2x to the 5th plus 6x. Okay, last example, and then I'll let you guys, I think there's some homework that you have to do Wednesday night, so you guys could probably work on that. But let's do 5x to the 4th plus 2, 3x to the 7th minus 7x. Take a second to think about that. LC is 15 and the degree is 11. So for this one, it's kind of the same as the last one, but you actually don't need to do as much work as you think you do. You don't need to FOIL this completely out, but I know that between what I could multiply, these two, if I multiply them together, would give me the largest exponent out of all of them. And I know that 5 times 3 is 15, and then x to the 4th times x to the 7th is x to the 11th, because this is just equals x to the 11th. So those are those ones. Do the homework problems so you can have a little bit more practice. I'll post the answers so you can check your work. And if you have any more questions, just email me. And I will be back on Friday to see you guys in person. So goodbye.